So when we have a pyramid, we will have a base and a tip wherein we'll have an axis. And same goes for if we are going for a cone, and we'll have a base and then we'll have a tip. And for a cylinder, we will have two bases, basically the bottom part and the upper part. And for the likes of cubes and cuboids, we do not have such tips, so it will be like this. And there are different types of solids. So we have prism. These are all prisms. Okay, these are all prisms. The first one is a triangular prism over here, and we have a square prism, pentagonal prism, hexagonal prism. All right. So basically, prisms are like, let's say, cylinders with edges. So basically, if we have a geometry, and if we extrude them, to come up with a solid with a definitive shape and sizes, then we get prism. As simple as that. Okay. So you can have, so basically, if you can call a circular, or you can call a cylinder as a circular prism also, if you may. Right. So however, we simply call them cylinder because of the already existing shapes and and its designated name. So we won't call it the circular prism. But the other geometry, if they are protruded, if they are extruded to form a shape, we call them prisms. All right. So probably when we talk of prisms, you might have an idea of this because probably in your high school or higher secondary school science projects with diffraction and on those physics experiments, science experiments with lights, the prism you use probably would be these triangular prisms. And instead of having a protrusion, when we have a tip, when we have a point where we extrude, or let's say we pull this particular center of this, when we pull the center of the geometry of the geometrical shape and form a solid, we get pyramids. So the first one is a triangular pyramid, and a triangular pyramid is a pyramid which has four sides. That means that four sides means 1, 2, 3, and the base 4. Right. So it's called the tetrahedron as well. So always remember this. When we say a tetrahedron, then that means we are talking about the triangular pyramid. And we have a square pyramid which has a square base and a tip with an axis. So basically we have ABC nomenclature and O as a tip of it, O1 and O1. Basically, for the tip, we want to call it different nomenclature, but instead of having a separate alphabet for it, we simply annotate it as one because basically this is a non-existent point. This is a non-existent point in the sense, like for example, point A, B, C, D, E, and O are very much more or less solid and identifiable. But the point O1, where the axis falls, this is more or less imaginary, and this can be the center of the center of this base where all the diagonals meet. All right, so we have a pentagonal pyramid here and a hexagonal pyramid over here. So in our projections, we are going to have different solids which are where the axis is perpendicular to the HP. So axis is this one, axis, where the axis is perpendicular to the HP, and where the axis is also perpendicular to the VP. And when we have axis parallel to both the HP and the VP, that is perpendicular to the profile plane, axis inclined to the HP and parallel to the VP, axis inclined to the VP and parallel to the HP. Up till here, for sure we are going to do it, but if time doesn't permit, we may have to skip this part, axis inclined to both the horizontal plane and the VP, as it takes a little bit of time for explanation as well as for you all to grasp. But the practice that we are about to do in the orientation of planes which are inclined to both VP and parallel to HP, you can have the idea. The first orientation we have is the axis of a solid perpendicular to the horizontal plane. HP means horizontal plane. Okay. So this is one of the basic positions of the solid. It is evident that if the axis of a right solid is perpendicular to the HP, its base will be parallel to the HP. All right. So whenever the axis is perpendicular to the VP, to the HP, the base is going to be parallel to the HP. So remember in the projection of planes, when we said that when a plane is parallel to either of the when a plane is parallel to either of the reference planes, meaning HP and VP, then it is going to be compulsorily perpendicular to the other plane. To VP, then it is going to be perpendicular to HP. If it is parallel to HP, it's going to be perpendicular to VP. So something like that. When an axis of a solid is perpendicular to HP, then the base is going to be parallel to HP. All right. So we'll have an example straight away. A square pyramid of base side 40 mm and axis 60 mm is resting on its base on the HP. Draw its projections when a side of the base is parallel to the VP and a side of the base is inclined at 30 degree to the VP, and C, all sides of the base are equally inclined to the VP. So before we proceed, we must know how a square pyramid is going to look like. All right. So a square pyramid is going to have a square base, obviously, and as it is a pyramid, it is going to have a tip, and that tip is going to be at a height of at an axis of 60 mm. So here we have it, a 60 mm above it. All right, 60 mm above the horizontal plane, or let's say 60 mm from the base is where the tip is going to be located. So now let's see the drawing. So here we have the 2D projections in already projected. So I hope you are able to visualize it. So basically a square pyramid. Say this is the square base, okay? Say this is the square base. So a square pyramid is going to have a square tip, sorry, a tip at right above the center. So more or less it's going to be something like this. So this is going to be 40 mm each size. It's 40 mm, and the tip is at from the center. You can have the tip at 60 mm above it. Okay. So when we look from above, we are going to see the square base and the square tip at the center, right? When we are going to look from the top. So this is exactly what we get. So when we look from above the square pyramid, so this is what we are going to see. All right, A, B, C, D. So the first condition is saying that when we are going to orient our solid in such a way that a side of the base is parallel to the VP. All right, a side of the base is parallel to the VP. Okay, so when that happens, look at this. The side AD here, this particular side is parallel to VP. So when it is parallel to VP, from the top view part, it is going to be parallel to our reference line XY, right? This whole reference line. Okay. So this point O itself is the tip of the pyramid, the tip of the pyramid. So when we look from above, we are seeing this. Okay, so basically it looks like a square with two diagonals crossed, as simple as that. And as it is a top view, we are annotating we are annotating it with small letters A, B, C, D. Now for the front view part, this part is the front view. The front view part is such that we are looking it from this direction. We are looking from this direction, and what we are seeing is a base this side, BC, right? BC, and the pyramid tapering towards the top. So this is what we see from the front in the first condition A, when one side of the base is parallel to the vertical plane. All right, I hope everyone can picture it.
Yes.
All right, is my voice clear enough for you?
Yes, sir.
Yes.
All right, okay, thank you. All right, now let's see the second condition. The second condition states that one side of the base, a side meaning one side of the base is inclined at 30 degrees to the vertical plane. So when it is inclined at 30 degrees to the vertical plane, that means that one side of the square base, so meaning that out of the first four sides, sorry, out of the four sides, we have chosen the side or the HCD to be inclined at 30 degrees to the vertical plane. So when it is inclined at 30 degrees to the vertical plane, it is now inclined at 30 degrees to our XY line. Okay, so now as we have this, all right, so when it is inclined, all we need to do is we start by drawing the line CD at 30 degrees, and then we proceed to make a square as per that inclination, and we have the diagonals or the sides of the pyramid, and then we have the tip over here. So when we look from above, we simply see it as like this, as simple as that. When we see from the front, now we are seeing 3 points. We are seeing on the base. We are now seeing point A, point B, and point C on the base, and we have the point O tapering at. We have the pyramid tapering at point O. So what we have now is point A, B, and C over here. And as we are seeing directly from the front, from the point O to point A, we see a line. From point O to point B, we see a line. Same goes for O to C. But D is behind us, right? When we are looking from here, D is behind us. When D is behind us, we can still show its position and then adjoin the points O and D with a dotted line. Okay, with a dotted line. All right, so that is how we are going to annotate hidden lines, or basically lines that are behind us, but if if it had not been behind this, we would still be seeing it. So that is why we are making the line with dotted or dash lines over here. All right, so now in the other point, third point C, it states that all the sides of the base are equally inclined to the VP. So in order for it to be equally inclined, there can be only one angle, right? Because as the line, as the angles of a square is 90 degree, as all of it is 90 degree, for them to be equally inclined to the vertical plane, it must be 45 degree. All right, because when it is 45 degree, the internal angle makes 45, internal angle makes 45, and here we have the internal of the square measuring 90 degree. So it adds up as 180 degree. All right, so that means that for it to be equally inclined, for the geometry to be equally inclined, for this particular case, which is a square, it has to be 45 degree. So when it is inclined at 45 degree, when one side is inclined at 45 degree, all the other sides are inclined at 45 degree. Okay, so you may be confused if you join AB and meet the line XY, so this part will be 45 degree, and same goes for if you had joined BC and still it would make 45 degree. All right, so for AD and DC it is more or less obvious. All right, so when it is inclined like this, we are having our top view like this oriented, and for the front view, now we are still seeing 1 point, 2 point, 3 points A, B, C, but now D is perfectly behind B. D is perfectly behind B, and as such, as it is perfectly behind an already existing line, we need not double this line with dash line. Okay, because if you put a dotted or dash line over here, then that's a suggestion that D is not perfectly behind B, and it is slightly at this is slightly at an angle, or it means that 45 degree is not true, meaning that it's somewhere around let's say 46 degree or 44 degree. If that is the case, then you will have a line over here, a small dotted line running parallel to OB. You will have OD. All right, but as it is 45 degree, as it is perfectly aligned, then D is perfectly behind B, and as such you need not have this dash or dotted line. So we have this. So far so good.
Yes, sir.
All right. Okay, so now let me proceed to the next problem. We have again a square prism of base side 40 mm and axis is still 60 mm and is resting on its base on the ground. Draw its projection when a face is perpendicular to the VP, a face is inclined at 30 degrees to the VP, and all faces are equally inclined to VP. It is more or less the same, except that instead of a pyramid, now we have a prism, right? So a prism is, as I have mentioned, is nothing but a protruded geometry, and that forms a solid. So from here we can see directly that a square prism is nothing but a cuboid, right? So if the question is, if the problem is telling you that a cuboid of base side such and such, then it means it is a square prism. All right, so just like this, it's even simpler than the previous one as it does not have a tip. So we can have this. The first condition is like this: when a face is perpendicular to the VP. All right. So when a face is perpendicular to the VP, it means that, so now when we talk of solids, we have different terminologies. When we said a side of a base, that means we are talking about the edge, one of the edges of that base. Okay. When we talk about the face, then we are talking about, okay, the side of a base is a line. Okay, it's a line. So it consists of point A and B. Basically, it can be point PQ also. It consists of 2 points and the line adjoining, sorry, the line joining those 2 points. But when we talk of a face, it talks of a plane. So that means that a plane consists of at least of 3 points, right? 3 corners. But if it is a square face or a rectangular face, then it is consisting of 4 points. If it is pentagonal, then it's going to consist of sorry, 5 points, 5 corners. So here we have a condition that says that a face is inclined at 30 degree to the VP. And normally, when we say a face, we tend to not think of it as the base. So when we say a face, we eliminate the base. Okay, we only think of the other sides. So basically, when we have a square prism, sorry, that's too tall. So basically when we have a square prism, so these are the base, right? These are the bases, and the other sides, the other four sides that creates the height of the prism, these are the faces. Okay, let's call them the faces. So here in our first condition, one of these four faces is perpendicular to the VP. So when it is perpendicular to the VP, so we are going to be getting an orientation like this. So the face AB21, so this particular face is now perpendicular to the VP, right? It is perpendicular to the VP. So here it is directly the line. In this particular orientation, we have to address it as a line because in the top view, we are only seeing it as a line, right? Because our solid is standing. Okay, so this particular line represents the whole face that we are talking about, and it makes 90 degree to the vertical plane, which means it is perpendicular to the VP, and in this drawing, perpendicular to the XY line. So this is our first orientation. The moment we orient it properly, then we get our solutions. So we have the base side measuring A, B, C, D, and the top part is also 1, 2, 3, 4. All right. So from the front view, as we are looking, okay, let me draw this in 3D. It's a bit difficult to draw, especially when you are using just a mouse for this. Uh, let's try it. Anyway, so the label goes something like this: A, B, C, D, and 1, 2, 3, 4. Right. So this is the solid in 3 dimension. This is our pyramid, sorry, prism in 3 dimension. So if we look from the front, we are going to have a front view. A and B is going to fall in one point, right? Because it is directly perpendicular. And D and C are also going to fall in one point. Same goes for 1 and 2 and 3 and 4. So we are going to have the front view as a single, not single necessary, as a plane. It's a plane, a simple plane like this. So and as such, 1 and 2 is going to fall under one point, 3 and 4 is going to fall under one point, and A and B are going to fall under one point, C and D are going to fall under one point. And as it's a front view, they must all come with dashes above. All right. The front view, that means the projections that falls on the vertical plane, which makes the front view, are annotated with dashes. Okay. All right. So I hope you can picture this. All right. Now when it comes to now here we have a line over here. It kind of denotes the axis. Okay, it denotes the axis. Actually, even without these also, this can still be correct. But many a times we are in the problem further on. The axis of a prism is also important because sometimes the question is going to, or the problem is going to aid us. It's going to direct us with respect to the position of your axis. Sometimes it's alignment, sometimes it's position from one of the reference planes, such and such. Okay, so that is why it is wise to mark your axis. But on this particular problem, if you do not mark your axis and the axis line also, it is okay. Now in our second condition, we have a face is inclined at 30 degree to the VP, right? A face is inclined. So here, just like the previous one, we are assuming the face CD 4, 3 to be inclined at 30 degree. So when we inclined, I hope you can visualize this as well. When it is inclined like this, and if we are looking from the front, so how many points are we going to see? From the front, we are going to clearly see the point, this point, and this point, and behind us is going to be this point as well. So when we are drafting, when we are drawing the front view, then we are going to have the 3 points A, B, and C from the base directly visible, 1, 2, and 3 from the top part directly visible, and D and 4 are behind us. So this is why we still annotate them, but with dotted line. All right, and we have the axis over here as well. So does anything? All right, so here in this particular example, it does not tell us anything about its position from the VP and the HP. So for simplicity of drafting, we are letting it rest on the horizontal plane, meaning we are letting it sit on the horizontal plane. Suppose if you have like a square prism right next to you, or something like a book, if you let it stand directly on your table, it would be like that. It is resting on the horizontal plane being your table. All right, and then it is now perpendicular to the horizontal plane as well, and we are orienting our solid in such a way that those two conditions are still met, but we are moving our plane in such moving our solid with respect to the vertical plane. So in the third condition, we have all of the faces inclined equally to the VP, or how does it say? All the faces are equally inclined to the VP, yes. So if all the faces are inclined to the VP at one angle, it has to be 45 because these are making 90 degree. And here, like the previous example, if the point D4 or the line D4 is directly behind B and 2, so we need not have any dotted line over here. Same goes for the axis, as the axis falls directly behind B2, so it will be a simple representation like this. I hope everyone gets it. I hope everyone knows why we have C3, A1 like this over here.
Yes,
Any
sir.
questions so far?
Yes, sir.
All right. It's because they are standing, let's say, behind each other, and that is why it is like this. All right. Now let's go to the axis perpendicular to VP. So everything is just the same as that. It's just that we are going to have a reversed front view and top view, as simple as that. Okay, so instead of our solid standing on the table, standing on the horizontal plane, now we are going to fixate it on the vertical plane. Like suppose if you have a nail in the sense, not your two nail, your fingernails, the nail that fixes your furniture. And if you have if you perpendicularly nail it on the wall, then that is going to be your representation of a solid perpendicular to the VP. Okay, something like that. So we have now a pentagonal prism. So meaning a prism which has a base of sides, or of having 5 sides and measuring 30 mm each, and the axis of that prism is 60 mm, and one of its bases in the VP, meaning that it is resting on the VP. All right, so one of the bases, a prism always have two bases, so one of its bases is resting on the VP. So when it is resting, when we say something like lying or resting or has one of the bases in the VP itself, meaning that that base is parallel to the VP itself. When we say a pentagonal prism has one of its bases in the HP, then that means that that base is in itself parallel to the HP itself. So in our condition here, we have a base of the pentagonal prism parallel to the VP, meaning that the axis is going to be perpendicular to the VP. Okay, so when we see a problem like in your question paper or something like that, no one is going to directly tell you that you are going to have a solution of a solid where the axis is perpendicular to VP. You have to interpret it from your question directly. Okay, so something like a basis in the VP means a base parallel to VP, and when we have a base parallel to VP, directly the axis is perpendicular to the VP. All right, so we have to draw the projections when a rectangular face is parallel to and 15 mm above the HP. All right. So here we have new conditions here. A rectangular face. We are talking about pentagonal prism. So which part makes the rectangular face? Now let's go back because my drawing from this mouse is not very much helpful. I can see. Yes. Now this is a pentagonal prism, right? Pentagonal prism. So a pentagonal prism has two bases and five faces. Each face makes a rectangle, right? As you can see, 1, 2, BA, AB 2, 1 makes a rectangle. I hope everyone can see this. BC 3, 2 makes a rectangle, right? So our question here, our problem here is that rectangular face is parallel to and 15 mm above the HP. So now in this particular illustration, our pyramid is standing on the HP, right? It is one of the bases on the HP. Now consider this in a sleeping position, all right, something like that, sleeping position of a pentagonal prism, and the base is now no longer resting on the HP, right? If it is sleeping, if it is in a sleeping position. Okay, so now in the sleeping position, the base is now going to be parallel to the VP and the axis is going to be perpendicular to the VP, which is now our current conditions. It's going to be. All right. So when you let that sleeping pentagon float, fly above the horizontal plane, then you are going to have one of the rectangular faces, of the prism is going to be parallel to the horizontal plane. Okay, so you have five faces, then you are going to make one face parallel to the horizontal plane. At the same time, the axis is perpendicular to the vertical plane. All right. Okay. And in the second condition, we are going to have a face is perpendicular to the horizontal plane. All right. So we have still remember a pyramid, sorry, a prism, a pentagonal prism, and we have five rectangular faces. So one of the face is now going to be perpendicular to the horizontal plane in the second condition. And in the third condition, one face is going to be inclined at 45 degree to the horizontal plane. Okay, before I show you the images, I want you to take a time and visualize it yourself, because the moment I reveal it, then you can coordinate with your perception versus what is going to be shown over here, and that is going to determine the level of your understanding. All right, in the meantime, can anyone tell me the internal angle of a pentagon? The other day we said internal angle of a hexagon is 120 degree. What about a pentagon? No one.
108, sir.
All right. Yes, it's 108, 108 degree. And you need to know this because you are going to draft this. You are going to draft this accurately. So whenever you draft it, you have to measure all those angles and all. So don't be uh, confused later on. Okay, it's 108. All right. I hope everyone has visualized their solids. So in the first condition, our face is parallel to the HP, right? So now our front view is now showing the profile of the pentagon. Now this face, the face, as I've mentioned, BC32, that face is now parallel to the HP. So now that means that it is parallel to our XY line. All right, in our first condition, so our first condition is met. So here, as I have mentioned, the axis will be more or less over here, wherein uh, where the central is here. It's not necessarily where it's not necessarily where the diagonals meet. So here we can see that the axis is situated over here, and the base, sorry, not the base, the side, not the face. Okay, sometimes it's a bit you have to think of many things when we talk about a face and we are representing it with line. I hope you are not confused, because we are seeing the front view of that particular face. All right, so the face is going to be this particular uh, 23 CB, BC23, or that rectangular face BC32. This is that particular face. Okay, and the reason why it is marked in dotted line is because in the top view we are looking from above. So that particular base, okay, I keep on calling it the base, that particular face which is beneath these lines are going to be shown in dotted line. Okay, all right, now we have B, C, D, E, A, B, C, D in one side. So that means on that side which is closer to the vertical plane, and 1, 2, 3, 4, 5 on the side which is further from the vertical plane. So that is how we are going to annotate it. So we have our top view like this, which is generated from our front view now, because the front view is now showing the profile of your prism. Profile means the actual shape, which shows the pattern of your prism. So from here we are making our top view. So A, B, C, D, E, 1, 2, 3, 4, 5, and we adjoin them, and then we have the top view of our first condition, front view of our first condition. And in the second condition, we have a face perpendicular to the HP. So remember, when we have a face, that means we talk about a plane, okay? But that plane is in two-dimensional drawing. Now a line is now a line because we are looking from the front. So this particular face, AB21, AB21, this particular face, okay, is perpendicular to XY line, or the horizontal plane, and that determines our second condition. So after we draw this, we make our pentagonal profile. Okay, after we make this AB21, we make this part, and after we draw the pentagon, then we project it below the XY line. Okay, and that length is the determinant is determined by your axis length, 60 mm. If by any chance the problem isn't talking about the length of your axis, you are free to assume it. Okay, but however, the dimension of the solids is always going to be determined by the length of your axis, and you must always look into that consideration. Our third condition is saying that one of the faces is now inclined at 45 degree to the 45 degree to the horizontal plane. So we make one side. Where is my cursor? Okay. we make one side, one face or one side at 45 degree, and then after that we draw the hexagon again at 108 degree, each measuring 30, each measuring 30 mm. And then after we align that, we have our top view. And now in that particular alignment, we have multiple points coming in the front view, in the top view, and that point is the center. All right. So you draw these lines, and if you were to visualize this, here is a minor mistake over here from the textbook. All right, here point 5 E is actually E5. This is actually behind us, right? If when we are looking from from the front side, this face, this line E5, not face, this line is going to be, sorry, this is a top view, not the front view. This is correct. All right. Yes, is my screen visible?
Yes, sir.
Yes, sir.
All right. Okay. I hope everyone understood.
Yes, sir.
So whenever we project solids, ourselves in order to draw the top view and the front view, which part is hidden and which part is not. So we must always be very careful. So especially when we move on to, by any chance we go on to projection of solids which are inclined to both the reference planes, then we are going to have multiple angles. Okay, multiple angles. So you must always get those angles accurately in such a way that you get these lines perfectly. In the sense, suppose this alignment, let's say this 45-degree alignment was, let's say, done incorrectly, and it is a little bit more than 45. Let's say instead of this E5 line, in this E5 line has been oriented in such a way that it is slightly overlapping A1, then your A1 line is going to be in dotted line, right, in your representation, because it is slightly beneath the E5 line. So if that is the case, then your projection is going to be rendered wrong. All right, so that is why you must always be careful with your angle, the internal angles, and especially when you go with the likes of hexagon and pentagon, and that is when it is getting a bit tricky. Okay, many a times I used to see that even from your seniors also, when it comes to pentagon, basically pentagon, hexagon, though more or less they manage. When it comes to hexagon, there are a lot of distortions, and be sure that you do not follow the same mistake. Now we have an axis parallel to both HP and VP. So when it is parallel to both HP and VP, now we are going to need a,
Sir, I want to ask you something in the previous question.
yeah,
Sir, why the line E5 is not dotted? Because as it is shown behind. So,
no, E5 on the third point, right? C point, on this point C,
yes, sir.
third condition, right? This one, right?
Yes,
Let me
sir.
explain it
Yes, sir.
again. We are looking from the top part. Okay, we are looking from the top part. Let me erase everything first. We are looking from the top. All right. So we are looking from the top to get this top view, to get this top view, right? So as E5 comes very close to us, see, D4 is the line that is going to be the closest to us, the line that's closest to us. The second closest is E5 and it's visible. And C3 comes next, still visible. And finally, we have A1. And the only line that's invisible is going to be B2 from above. But we are still showing that because we are annotating its presence. Understood?
Yes, sir.
We are looking from above. Okay. For a top view, we are looking from above.
Okay,
And
sir.
for the front view, we are looking from the front. And that is what we did in the previous problem. Now in this particular problem, as our solid is perpendicular to VP, so that means that as I have illustrated, so it's like a nail that is nailed to your wall and now it is protruding out your wall. So that is something like that. Is it clear now?
Yes, sir.
All right. So now we have an axis of a solid which is parallel to both HP and VP. All right. So now just remember the time when we had a plane which is perpendicular to both HP and VP. VP. When a plane is perpendicular to both HP and VP, it is creating a line on both the top view and the front view, right? Sometimes our plane is a square plane, sometimes it's a circular plane, sometimes it's a triangular plane, and so on and so forth. So we need to see the profile of our plane, right? A plane has a shape, a size, and all those things, and if we only represent it with a line, then it is not correct. So likewise, when our solid is okay back in planes, we require the third profile plane, right? The side view to get the side view in order to get the profile of the plane. So likewise in solid in parallel in an axis parallel to both HP and VP, we are going to get a solid where we are only seeing the sides. Suppose if we have a prism, we are only going to see the sides and we are not going to see the profile. The profile is what makes the shape of the solid, right? If it is a pentagonal prism, then that pentagonal shape is where the profile is or where the base is. We need to see that, right? If it is a hexagon, we need to see the shape of a hexagon. So when they are parallel to both the reference planes, we are not going to see the profile in the VP and the HP or the top view and the front view. So we need the third plane, the profile plane. All right. So in our problem, we have a pentagonal prism of base side 30 mm and axis 60 mm is resting on one of its rectangular faces on the HP, meaning it's resting, sleeping on the HP with an axis parallel to the VP. Draw its projections. So now the question is not telling us that it is parallel to both the plane, right? But as I have mentioned, as one of the faces is resting on its angular, on its rectangular faces, so more or less the at least a face is already parallel to the HP. The moment the axis is parallel to the VP, all right, remember this. The moment the axis is parallel to the VP, axis parallel to VP means the whole solid is going to be perpendicular to the profile plane this time. Okay, it's going to be perpendicular to the profile plane. All right, so here now that is why we have our profile plane. Remember the other day we were drafting and we are showing the profile plane to be on this side. If you do this also, that is entirely fine. Okay, it's fine. There is no there is no direct, there is no um, regulations or there is no rules that your profile plane must always be on the right side. It can be on the left side, it can be on the right side also. It is fine as long as it shows the profile. All right, now we have a prism. We know that the base is resting on the not the base, sorry, the face of the, because the base is this one, the face is resting on the horizontal plane. All right, the face is resting on the horizontal plane, and the vertical plane, sorry, and the axis of that solid is parallel to the vertical plane. When an axis of a solid is parallel to the vertical plane, then it is perpendicular to the horizontal, to the profile plane, sorry. All right, I'll just see if I have a 3D of this. I think I can make an iteration. Just a minute. So we have a solid. All right. So now we have a pentagon. Oh, sorry, pentagonal prism. We have a pentagonal prism, and in this particular orientation, we have the axis. Now I hope you can see the axis. Now we have the axis perpendicular to the VP, right? When it is perpendicular to the VP, so that axis is parallel to the HP, okay? But the moment we are going to make this axis parallel to the VP, it's going to be perpendicular to the profile plane, all right? Now let me rotate this again. All right, so now our pentagonal prism is oriented like this, okay? See this? We have our axis parallel to the VP and our face, one of the faces of the pentagonal pyramid resting on the horizontal plane. So our pentagonal prism is situated like this. All right, axis parallel to VP that directly makes the axis perpendicular to the PP, profile plane. All right. Now let's see this. So what does our condition say? All right, I hope you can see it. Yes. Oh. All right, so here, if we jump to the 3D, in the front view, we are going to see only this, right? In the front view, we are seeing our pentagonal prism as more or less uh, as a rectangle, right? In our front view. And in our top view, we are also going to see it as a rectangle, right? So where is the pentagon? We are not seeing the pentagon, the shape of the pentagon in the top view and the front view. So that is why we need the profile plane to have the side view, right? So here we are able to see the pentagon size or pentagon shape. All right, so now if I jump to this, here you will be able to see it. So as our pentagon is resting on the horizontal plane, we need, and it is parallel, the axis is parallel to the VP, we need the side view. We need the profile view. So we are starting from the profile view, and as such it is easier, as we tend to draft in this direction, it is easier for us to be able to go in this direction and get everything right. Okay, so we first draw the profile. All right, you don't have to, when we draw the profile, we don't have to start, labeling the points. We can simply draft a pentagon of base side 30 mm, meaning that all of these are 30 mm, all of the sides are 30 mm, the base sides are 30 mm, and then we have our pentagon ready. And in order to have the front view, so we are now, as this is the profile plane, we are now putting it from in this direction, and we decide to have one line as a starting point. Remember, the question does not tell us anything about the position of this uh, solid with respect to the VP and the HP. So we can, with the HP, though it is saying that it's resting on the horizontal plane. So that means that the distance of the solid from the HP is going to be 0. It is resting on it, so it is touching the horizontal plane. So we have that. All right. So now here, for the front view though, in with respect to the vertical plane, as it does not tell us the location of the face with respect to the vertical plane, so we can simply start from here wherever we want to. You can start from here also, you can start from here also, but it's your choice. So here we are starting from this particular location. So as from our visualization, we know that we are going to see it as a rectangle only, so we draw a line as simple as that. And then this, as there is this part, so we are making a straight line over here. All right, so remember this line corresponds to two more lines behind it. So consider to be looking it from this side. Okay, consider to be looking from this side. So you will have this line ready. All right, this line ready over here. And this line C3 is also going to be directly behind this. So we need not draw any other line. We need not draw any dotted line like that. Okay, simple as that. And what's next? Same goes for A1 line as well as B2 line. So they are simply going to be located over here. So the exist line, though, it's as simple as that here. All right. So now for the top view, as we are to look from above, we are going to annotate that. All right, we are going to take this line. I think I have already told you in the previous class in planes, but for some of you who might have be absent, I'll repeat the whole process again. When we are employing a profile plane for our view, all right, so we are making every point to the XY line. We are projecting the points to the XY line. And then from here, on our X1, Y1 line, we can make an arc with this point as a center like this, as shown in the figure, or we can simply make a 45-degree line also, all right, because it's still going to be the same 45-degree line like that. All right, it's still going to drop at the right point, and from there we are going to project it on the right side. So it comes from here. We have E and 5, right? E and 5 points come here, and then it goes here and it meets E, because from here also C and E are here. So C is on the upper part, E is on the lower part here. Now remember, we are looking from a top. All right, we are looking from a top, and as it is 5 is from this side, so as 5 is from this side, so we have 5 over here. And from here also it comes here, point A and 1. And now as we are looking from this top part, A is beneath these lines. A is beneath the upper part. A is on the lower side. Same goes for 1, same goes for B, and same goes for 2. So when we join these lines, we are going to be getting dotted lines for A1 and B2. For D4, it goes on like this. We get a point over here and here, and finally we get D4. And D4 is a solid line because we look from the top and it is the line that comes closest to us. Same goes for E5 and C3. They are still visible. All right, so it goes on like this. So when a solid is parallel to both the horizontal plane and the vertical plane, we have a profile plane, and our projection will look like this. Okay, any question? And before that, When we employ a profile plane, we have our reference line, XY line, as well as a reference line in aid of the profile plane. So, which is something like this. So it would be something like, if this is our XY line, reference line going, this still would be our X1, Y1 reference line. Okay. In the vertical part, our XY line will go on like this. All right. So any question?
Nope.
All right, then I can proceed. Now we have some miscellaneous problems over here. Let's see. We have a hexagonal prism of base edge 30 mm and axis 70 mm, which has its axis parallel to and 50 mm above the HP. Its base is parallel to the VP and an edge of the base is inclined at 45 degrees to the HP. Draw its projections. It's a hexagonal prism, so there will be a hexagonal base and there will be a protrusion of that base at up to 70 mm, and now its axis is parallel to and 50 mm above the HP. When the axis is parallel to the HP, when the axis is parallel to the HP, it can also be, perpendicular to the VP as well, perpendicular to the, perpendicular to the VP as well, perpendicular to the PB as well. But its base is parallel to the VP. Now we have a condition which clearly states that the base is parallel to the VP. So that means that when the base is parallel to the VP, then it is perpendicular to the VP. When the base is parallel to the VP, the whole solid is perpendicular to the VP, or the axis is perpendicular to the VP. And an edge of the base is inclined at 45 degrees to the HP. Draw its projections. All right, so it will be something like this. The hexagon, when the base is parallel to the VP, the axis, the whole thing, the whole solid is perpendicular to the vertical plane. So that is why we are going to see the profile on the front view, the VP. All right, so we have something like this. All right, here now it is telling us specifically about the axis. The axis is parallel to and 50 mm above the HP. So our drawing has to be in such a way that our axis point from this center point to our XY line, it is going to be 50 mm. All right, so what you can do is, if you start from XY line and if you project the 50 mm point and start drawing your hexagon. Actually a hexagon is like, if this is, it's making, a hexagon is making 6 equilateral triangles, each measuring the hexagonal size, okay, 30. So if you were to start from the center also, you can still make it, but it would be a bit problematic because there is going to be a line, as our condition states that the base is inclined at, one of the edge of the base is inclined at 45 degree to HP. So this edge, one particular edge, is going to be 45 degree to the HP, okay, horizontal plane. So if you were to start from the center, from inside outward part, it's going to be a bit problematic. All right, you can still do that. Simple way of doing this is going to be, you start directly from this part, C3D4 face, and make it 45 degree to XY, and from then onward you proceed to complete your hexagon, each internal angle measuring 120 degree, and you will get that. And from the center, and from your center here, this center is where the diagonals meet, you write your XY line 50 mm below, right, 50 mm below, and you project the points downwards to get your top view. Here is the situation I was explaining before, or I was warning you before. Your angle, you are going to make 45 degree first, and then after that you are going to make 120 degree. So you are going to have some unconventional degrees, like 120 plus 45 is going to be somewhere around um, 165 degrees somewhere. You are going to get something like that. So you must be careful. Now, something like this. For example, if we look from the top here, it's very clear that this is going to be the first point that's going to be visible, second point visible, third point visible, and then fourth point visible. And then these 2 points, they are going to be, these two lines are going to be beneath on the lower side. They are not going to be visible. All right. So if you mess the angle, then somehow if this part is invisible, then it is going to be a wrong, let's say, projection. All right. So here we have some composite shapes. Let's not delve too much into it, but let's see what this can be. A hexagonal prism of base side 25 mm and axis 60 mm is resting on one of its rectangular faces of the HP with the axis perpendicular to the VP. A right circular cone of base 6 of the 30 mm diameter and axis 45 mm is placed centrally on top of the prism. Draw the projections of the composite solid. Okay, a right circular cone means that the axis of the cone is perpendicular. Okay, perpendicular to the base. The axis of the cone is perpendicular to the base of the cone, that is the right circular cone. So a right circular cone of base for 40 mm diameter and axis 45 mm is placed centrally on top of the prism. Centrally meaning that it is going to be directly above the prism, wherein it's going to, the axis of that particular cone resting above the prism is going to be centrally located on that face where it is situated. I hope you get it. Like for example, here you can see the front view of one of the faces of the hexagon on the prism, and another face where it is resting on the horizontal plane. All right. So one face is resting on the horizontal plane, and on top of that is a face which carry the right cone, right circular cone, the right circular cone. All right. As our hexagonal prism is of 25 mm and as the base of circular cone is 40 mm, we are going to have protrusions. So this part protrudes out. So more or less we have something like this for the front as a top view. So front view, sorry. And for the top view, we will simply have something like this. A circular base from the center, we have a circle like this, and the top like this. And then beneath this, we are going to have our line. So that means that typically this point is going to be the one that is visible, right? But now as a cone above us, we can simply draw this line as an invisible line like this. Same goes for this line. Not same goes for these lines, as this protrusion is not overlapping it, as it is not above it or overlapping it. These lines A1 and D4 are going to be visible. Okay, looks complicated, but it's very easy. Now let's jump to another condition. Now we are going to have a solid inclined to the reference planes. When we have an axis inclined to the horizontal plane and parallel to VP. Now the inclination is going to be largely, it's going to be largely dictated with reference to the axis. Okay. Because when we talk about a solid, we have different faces, right? We have different, sometimes it may refer you with the likes of the diagonal of one diagonal and one face, but majority of the time we talk about the axis. Okay, when the axis of a solid is inclined in the first condition, when the axis of a solid is inclined to horizontal plane and parallel to vertical plane. All right, I hope everyone is still with me. Now we are going to have some angle, and it is going to be If you had already, if you already practiced with your planes inclined to one of the reference planes, then this is not going to be too new, and it's going to be, a continuation of what you have already learned. But if you haven't practiced that yet, and if you have slightly forgotten a few bits about what we did, it's going to be something new again. So please pay good attention. Now let's go on directly to the problem. A pentagonal prism of base h, it's a prism again, 30 mm and axis 60 mm rests on an edge of its base in the horizontal plane. Its axis is parallel to vertical plane and inclined at 45 degree to the horizontal plane. Draw its projections. Right, now we have an axis parallel to VP and inclined at 45 degree to the HP. All right. So now when we have must always consider these conditions very importantly, and we have an axis parallel to VP. Parallel to VP means more or less you can, uh, you can rotate your, remember the time when I was explaining with your notebooks and something like that. So consider a notebook or a textbook, as textbooks are most of the time are thicker. Consider a textbook and attach it on your wall, okay, with one face directly attached on the wall, and then you can simply rotate it like as if you are rotating the wheel of a car. All right, you can rotate it. So when you rotate it directly adjacent to the wall or directly touching the wall, then you can rotate it, right? That means that one face, that particular face touching the wall is parallel to the vertical plane. But when you rotate it, it is still parallel to the vertical plane. But the moment you rotate it, you are making inclinations with the floor or with your wall, with your table, which is the horizontal plane. Okay, so such is our condition here. Such is our condition here, where we have something like a prism which is parallel to the vertical plane. So if you take away your book from that wall without touching it, right? So your book is now not touching your wall, but you make sure that it is still parallel to the wall. It is still parallel to the wall, and if you rotate it, then there is no way in that rotation the book is going to touch the wall, right? Because it is parallel to it. As long as it is parallel to it, whatever rotation, it can be 360-degree rotation, 120-degree rotation, 75-degree rotation, any rotation, it's not going to touch it. It's not going to touch the vertical plane as long as it is parallel to it. Okay, so that is our condition. So that means that more or less our inclination is not going to make uh, any angle to the vertical plane. So that is what parallelity of the object is talking about. Now our object is inclined at 45 degree to the horizontal plane. All right. So in our drawing, we start by eliminating this inclination first and making sure that when it is parallel to VP, we let it perpendicular to the horizontal plane first. Okay. We let it perpendicular to the horizontal plane first. And remember, when it is parallel to the vertical plane, the shape, or let's say the projections that fall on the VP, which means the front view, is always going to be the true dimension of that particular object, right? It is not distorted in any way, so it is always going to make the true shape on that particular plane, which is the vertical plane for our condition. All right, I'll repeat that. When it is parallel to one plane, then on that plane, the projection is always going to tell the true shape. True shape in the sense it's going to talk about the true length of that particular solid, and let's say in terms of its axis, it's always true. All right. So now that is why we are going to let that parallel status not be disturbed, but there's inclination at 45 as it is going to show no longer a true length on the top view part as it is on the HP. We are going to make it perpendicular first to show the true shape first. All right, so we first start with a condition where the solid is parallel to the VP and perpendicular to the horizontal plane. So basically we are going to have a standing pyramid, sorry, a standing prism, a standing pentagonal prism. All right, and as we are going to our, or we can orient this in any direction, right? We can orient this in any direction, but we have a condition which we must always take into consideration, which is the solid is resting on an edge of its base on the horizontal plane. As it is going to be tilted at 45 degree, there is going to be one point where it is either closest to the HP or touching the HP. Our condition clearly states that it rests on the horizontal plane, meaning that it is touching the horizontal plane. So is it touching at a corner or is it touching at a side? It is telling us that it rests on an edge. Edge here means the side. So how many edges do we have in a pentagon? We have 10 edges, right? 1, 2, 3, 4, 5 on one base, another 1, 2, 3, 4, 5 on one base. If we consider the sides also, then it's going to give us not only 10 edges, how much? 15 edges. Yeah, I believe it's around 15 edges, and we are going to get 15 edges. So it is saying that it is eliminating the face. So out of the 10 edges of the base, it's resting on one of the base, one of the edges of its base. So we are going to keep in mind that as we are going to tilt it, when we are tilting it, the edge, one particular edge must still be staying intact. All right. So if we are to tilt it, then we are going to make sure that that one edge is going to be our point of tilting, in the sense that that edge is going to be remaining intact. It's going to stay there. All right. So that is why we are making that particular edge perpendicular to the vertical plane. All right, like this, because we are going to tilt it in this direction. We are going to tilt it in this direction at 45 degree. So we make sure that that particular edge remains the same. So we make it perpendicular to the VP. All right. As we are still on a pentagon, let me show it over here again. We have a certain pentagon. All right, let me try this. All right. So now our pentagon is, we have an axis somewhere over here which I may have not shown. Let's put it like this. Probably the axis is not right at the axis. I should have gone with this. Sorry. Anyway, so now this axis is supposed to make 45 degree to the horizontal plane, while at the same time, one of the edges of the base must remain intact on the horizontal plane. It is resting on the horizontal plane, right? So in order for me, this is the front view, in order for me to rotate this and making 45 degree while still being parallel to the VP. All right. So in order to be doing that, I will be able to rotate this. Now let me rotate this whole thing. All right. Now it is rotating at 45 degree. Our axis is rotating at 45. Axis is rotated at 45 degree to the horizontal plane. It is at 45 degree to the horizontal plane. And the condition is that the axis is parallel to the vertical plane, right? Is it still parallel to the vertical plane? Let's see. Yes, it is still parallel to the vertical plane. See this? This is the vertical plane or the XY line, and our axis is still parallel to the vertical plane. All right. So now we have our conditions met like that. So the edge of the base is touching the horizontal plane. The axis is at 45 degree to the horizontal plane and still parallel to the vertical plane. All right. So how do we do that manually? So how do we do it? We first get our pentagonal base or our top view as if our solid is perpendicular to the horizontal plane first in such a way that we get the true profile of our solid first. Okay. And then we have our front view. So now we have our front view. So the front profile is going to remain the same even if we rotate it. All right, I'll explain that from here again. Remember, this is our front view, and let this be gone for now. Hmm. All right, now let's see the front view directly. See, on our first condition where our solid is perpendicular to the horizontal plane, this is our front view, right? This is our front view. And when we rotate it at 45 degree, the dimension still remains the same, right? If this is, let's say, 50, 60 mm, then this is still 60 mm. This is still 60 mm. I hope you can see my cursor. And let's 40 mm. This is still 40 mm. Everything remains the same except the orientation with the horizontal plane. All right, because our axis is parallel to the VP, so the whole thing is not going to change its dimension on the front view. All right, now going back. So now we obtain the front view from our top view when it is perpendicular. And after we obtain this, we are going to rotate it in such a way that this axis, now remember, this is the axis. Actually, when the axis is a reference, we can always annotate this one as 0 dash and 0 1 dash because that is our axis, right? On the top view, we will have 0 and 0 dash, not 0 dash, 0 1, 0 comma 0 1. We will have that. All right, we can have that because the axis is our reference point here. So our axis will be situated here, our axis will be situated here. So as this is the top part, this will be 0. As this is the base part, this will be 0, 1. All right. After we get our front view, we rotate it following or using all the dimension from the obtained front view. So that means that the distance between A dash and CD is still going to be the same. Okay. And then we make sure that the axis is at 45 degree. All right. Now the next part is to obtain the true top view. In order to obtain the true top view, we project this point A dash, let it go down, and from A1 we project a line to get A and the position of 1. And this position of 1 coordinates with the front view 1 dash, and we get 1. And so forth, we get all the other points to get our top view, true top view. And in this part, you must always be very careful which part is visible and which part is not. Again, this is where your seniors used to make mistakes, okay? Where the hidden line is going to be the top, the non-hidden line is going to be. Remember, when we are looking from top, we are going to look from top to bottom. So the top part comes at 1 over here, and 2 and 5 is also going to be there, and 3 and 4 is also going to be there, and A is also going to be there. All right, and somehow B and E is also going to be there. All right, we are looking from top and we are looking at a prism over there. So this part is going to be hidden. Now remember, this may be a bit confusing from the previous one because this seems to be lower, especially B and E. B and E is lower, so why is still it be visible? Because this is, we are looking at the side, we are not looking at the profile. Okay, we are not looking at the profile, we are looking at the side. So even though this B and E seems to be below A, but when we look from it, this is a face and this face is slanting downwards. So this is a combination of your perception and your understanding of the object, which would be a pentagonal prism for this case, and your visualization as well. Okay, so in the front view, as this is the front view, we are looking at the side, we are not looking at the profile. So all of these are visible, right? All of these are visible. So that means that when we project it on the top view, this part is also visible. All right, this part is also visible. B, E, and 2, 5, meaning that there are 2 points which are supposed to be visible. On the front view, however, B and B2, B2 is the actual line over here. Let me erase it first. All right, B and 2 are actually the ones which are visible. Okay, and E and 5 are directly behind 2 and B and 2. So we are not writing it with a dotted or dashed line over here. However, when we look from a top, all right, when we look from a top, so we are going to assume partly, as we are going to tilt it, as if we are looking it from this side. Now this is being tilted. So this A1 and E5 are visible, so is B2. All right, A1, B2, E5 are visible. So now what's not visible are going to be this line. Okay, as is going to be beneath A1 now, because it's like that. All right, now 3, 4 is still visible because now we are going to see this face. And what's not going to be visible is going to be CD and the lines adjoining it. All right, so this is going to be highly dependent on your ability to visualize what you are going to project. All right, A1, the top part, E5, the second most, B2, and same level as E5. And as for D4, and as for 4, 3, and CD, the thing is that remember that part where we have the formula which gives us how to annotate our, yes, still remember this. So 1, 2, 3, 4, 5 is always the top part, and A, B, C, D, or the alphabets. The alphabets form the lower part, and the numeric form the upper part. So in that consideration, for this particular example also, when we tilt it, the top part is still visible. 1, 2, 3, 4, 5, and from the base we have D and E hidden, and whatever line connects to that are also hidden as they fall below. All right, so in order to come up with these points, they coordinate with these points first, and from the points of the true front view. So if we look at the three-dimensional view, front view is like this is the true front view, and if we look from above, this is three-dimensional, so it does not give us anything about the dotted lines and all, but you can see that this line is a bit clearer. This is the top part, 1, 2, 3, 4, 5 part, right? This is the base part, A, B, C, D, E part. So that means that this line, this line, sorry, this line forget it. So these lines are going to be directly visible along with entirety of this hexagonal profile and these lines. All right. Now that is when an axis is inclined to horizontal plane and parallel to VP. I believe we'll have more exercises over here. So we have a pentagonal prism again of base side 30 mm and axis 70 mm has a corner. Now instead of the side, now instead of an edge of the base, it has a corner on the horizontal plane. And the axis is inclined at 45 degrees to the horizontal plane, same condition. Draw its projections when the plane containing the resting corner, all right, the plane containing the resting corner and the axis is parallel to the VP. So now we have to think about it. We have a, sorry, we have an axis still parallel to the VP, and we have an axis still parallel to the VP, and an axis still inclined at 45 degrees to the HP. But our condition is now such that instead of the edge on the HP, we have a corner on the HP. Okay, it should be a corner, not a corners. It has a corner on the HP. All right, so we have to draw a projection when the plane containing the resting corner and the axis is inclined to the is parallel to the VP. Axis is parallel to the VP, and the corner containing the the plane containing the resting corner is parallel to the VP. I want you to visualize it first before I show it. How would you start? As it is a corner, we have a pentagonal prism. All right, now let's go. Yes, just look at these and try to connect the different points, how it started, how it's proceed. Anyway, the image is clearly telling us first stage and second stage. So the first stage is that we are still assuming, or we are first starting with the assumption that our solid is perpendicular to the vertical plane, to the horizontal plane first, and the axis is parallel to the vertical plane. Okay. All right. Now let's see. All right. So now we are first assuming that the whole plane, the whole solid is perpendicular to the to the horizontal plane. Now we are still going to tilt it. Okay, we are still going to tilt it, and that is why our anchor point, or the point where we tilt it, matters. In the first condition, it is an edge which is on the horizontal plane, right? Now we have a corner on the horizontal plane. So that is why we must orient our uh, pentagonal profile, our pentagonal prism, in such a way that this is the corner which is going to stay intact in the horizontal plane. All right, which is going to stay intact in the horizontal plane. All right, so we first proceed that, and then we eventually get our front view, which is not going to change its shape if we rotate it as well. So likewise, similarly, we have a plane. So we have our axis still going on. So the axis is important, as I have mentioned. Okay. So in order to get the axis of a pentagon, what you can do is that in order to know this, you can simply get the line like this. So you will have a bisector, a segment. You have a bisector over here. It bisects the line, and the midpoint of that is going to be your axis, because again, if you have a bisector over here and a bisector over here, so that is going to be the point where the bisectors meet. So that is going to be your center of the pentagon. That is going to be where your axis is. All right. So now this is important because it is the axis which is at 45 degrees to the horizontal plane. So we let that axis to the horizontal plane. All right. Axis to the horizontal plane. And then we have, from these points, we put it down. We put it down. Sorry, we project them down to get the corresponding points. Okay. All right. Now that we get all our points, when we join them, we must do our visualization again in order to not mess up the lines which are hidden and the lines which are not. Now remember, when we tilt it like this face is going to be very much visible, right? Because we are going to tilt it this way and it's going to be open. So A1 to B is visible, and this part is also, the whole profile of this is also going to be visible in the top side, 1, 2, 3, 4, 5. The numeric part is always on the top side, so it's visible. And as it is a pentagon, as it resembles slightly looking from this side, this face as well as this face is also going to be visible. So A15E is visible, BC32 is visible. So the rest, which means that this particular corner D, the point of anchorage, that particular point, which is, or that particular corner, which is in the horizontal plane, is now hidden. Same goes for the previous question also, that particular H which is in the HP is below it, which is hidden. So, and as such, we have this. All right. So there is this question. I think this question does not make much sense over here because it says the plane containing the resting corner is parallel to the VP. Actually, a corner is a point where three planes meet, right? So there cannot be one particular plane which which contain this particular plane specifically. So I believe that whatever explanations it may have in these particular stages, which I believe it doesn't much, this is not actually, this is a mistake. The plane containing the resting corner and the axis is parallel to the vertical plane. So if we were to look at the plane containing the corner, it can be ABCD is the plane containing the corner D. DE54 is the plane containing D. So C34D is also containing the corner D. So I don't think this is not making much sense. Suppose if it says something like the plane opposite to the corner is something something, then we could have oriented like this. So I believe this particular section is not quite valid for this explanation. Plane containing the resting corner. All right, it can be the line containing the resting corner and it will make much more sense. All right, sorry. So if it says the line containing the resting corner, then that means that the line that originates from that corner. So that means that this DE, if this is point, not DE, D4, if this is the corner that is resting on the horizontal plane, then the line D4 as well as the axis is 45 degrees to the horizontal plane. That would make much more sense. Let me correct this. All right. I hope everyone understood the process. I will take that as a yes. All right. So when we have conditions like this is very much similar, so I won't ponder on it. Let's see. Problem 11.12. When we have something like this, now a hexagonal pyramid of base h 30 mm and axis 60 mm has a triangular face on the ground and the axis parallel to the VP. Draw its projections. So here it does not tell us anything about the inclination and nothing much. All right. So let's ponder upon it, how this is done. So we must visualize, okay, it's a hexagonal pyramid. Okay, we have different ways of uh, orienting it, right? So here is when the first step is always very important. We are going to let it rest. We are going to let it rest on the horizontal plane. What is going to rest? Sorry, we are going to let one of the triangular faces. Remember when we said that a pentagonal prism has rectangular faces. Now a pyramid always have a triangular faces, right? So a hexagonal pyramid is also going to have six triangular faces, and now that particular face is going to be resting on the horizontal plane. Something like this we are going to achieve. Okay, it's going to rest. So how do we start off? Let me just check if I have that model. I might have it, might not have it. All right, these were first terminal. Okay, probably I may not have that. Now let's see. So we are going to let it rest on the on the triangular face. That means that we are going to have one entire face. Face means a plane. Okay. In our first example, before, we have an edge touching the horizontal plane, right? An edge is resting on the horizontal plane here. Okay. And here a corner is touching the horizontal plane. All right. So in this particular condition, we are going to have one entire face resting on the horizontal plane. All right. So that means that we are going to let it entirely flip. We are going to let it entirely flip. Let me make an example over here. Let it be like this. All right. So now we have a pyramid. Hexagonal pyramid, and we are going to make in such a way that one of these faces, now it has six faces, right? One, two, three, four, five, six faces and one base. So one of these faces is going to rest entirely on the horizontal plane. So in order to do that, we have another restraining condition. Our question is saying that this is parallel. This axis is parallel to the vertical plane. Okay. Right now it is parallel to the vertical plane, right? Parallel to the vertical plane means that, yes, it's like this. And yes, if I look from above, it is directly perpendicular to it. It is perpendicular to HP and parallel to the VP. So in order to be parallel to it, we can simply rotate it in 180 degree. 180 degree means 360 degree, but in two dimensional only. This along this face only, right? That rotation can happen along this face only, like this only. All right. Suppose I have all right. I can rotate it. Sorry. Yes. Along this direction only, I can rotate. As so that means I do not break its parallel nature to the VP. Okay, along this direction only. See this? Along this direction only. All right. So, and in order to not break that, I must make sure that it is rotated in that particular direction only. And when it is supposed to be rotated, I am going to make this one face directly rest on the horizontal plane. All right. So as that is the case, I must flip it, right? I must flip it. Now, if I were to flip it in that direction, now let's see what happens if I flip in that direction to let it sleep. A bit restraining here. Now it kind of sleeps, but the thing is that it's it's not sleeping on it's not going to sleep on a face. It's going to sleep on a line, right? If it were to sleep like that. So I must orient this carefully in such a way that this line is this particular edge or any of the edges is perpendicular to the vertical plane. Right, let me try that. No, no.
Mm.
I may not have the perfect 90-degree over here, but let's. All right, more like it. Let's try it like this. All right. So when I have this side perpendicular to the vertical plane, then when I flip it in that direction I was talking about, then we are going to be able to have this face entirely sleep on the horizontal plane, entirely rest on the horizontal plane, right? So it will be something like this, right? So our axis is still parallel to the VP. If you look from above, our axis is still parallel. This is the axis, sorry, this is the axis, and this is the VP. Our axis is still parallel to the VP, and our face of that hexagonal prism pyramid is sleeping on the horizontal plane. So we first orient our vertical, this thing, our pyramid in the vertical direction first, vertical to the horizontal plane first, and we get the front view. We get the front view. All right, we get the front view, and we simply flip this, making sure that this 0DE, 0 or ODE is on this. So that means that we have our true front view. We have our true front view, and from then on, we project it like this, and we get our pyramid, like our pyramid rested on the horizontal plane like that. All right, so once we flip it, as you can see from the front view itself, which ones will be visible and which ones are not. So it's very clear that whatever falls between AB, like over here, they are all going to be visible. All right, as it topples, this base is going to be entirely visible. And if from these points to this also visible, corresponding to this, and these are also still visible. Okay, so the only faces invisible will be the faces corresponding to the ones that's sleeping on it and the ones directly adjacent to it. All right, so on questions like this, when it does not tell much about its orient, it is inclined at so and so. When it is resting on one of the sides, basically on these kind of questions will only this kind of problems only comes from pyramids, okay? Because pyramids, as it is already aligned in the sense, pyramids are the one that comes with angle, right? Like this kind of angle. So in its altitude position, so as it is like this, then you would be able to proceed on by making it stand first, by making it stand vertically on the horizontal plane first, and then proceeding it on with the way we used to do it in the previous projects as well. So for example, if this question is saying that it has a triangular face not on the ground but on the vertical plane and the axis is parallel to the HP, then we are going to simply reverse it. Reverse, this part will come up, this part will go down. As simple as that. All right, now moving on. Now we have a similar situation over here. Now instead of resting on a face, now let's see this. What do we have? A hexagonal pyramid of base, so and so, and axis 60 is lying on a slant edge. Right, it's not the face anymore. It's on a slant edge on the ground with the axis parallel to the VP. Now axis is parallel to the VP. Draw its projections when the face containing the resting edge are equally inclined to HP. Now this is correct. Face containing the resting edge are equally inclined at the HP, and this is for us. This is like a restraining or a condition that restrains our drawing, our drafting. Okay, so we can have many edges, right? We have slant edge. How many slant edge do we have? We have 6 slant edges from the 6 faces here. All right, so one of these edges is now sleeping on the horizontal plane, and the axis is parallel to the vertical plane. All right, axis is parallel to the vertical plane. And when one of these edges is sleeping, for example, when this OD is sleeping, it is going to make the adjacent planes, or let's say the planes, as the question is saying, the face containing the resting edge, the faces containing the resting edge, which would be these two edges, OCD and OED. These faces are equally inclined to the horizontal plane. All right, meaning that when it sleeps, this part is going to be making a certain angle, and this part is going to make a certain angle to the horizontal plane, and they are equal. I hope you can visualize it. When it sleeps on OD, right? It is staying over here. So the face, let me do it over here. In the previous example, we are letting it sleep on the edge. Let's create this again. Let me make it solid this time. So we are going to rotate this. All right. And with that rotation, now see this, when we rotate it and let it sleep, these are the two adjoining faces or the faces containing the edge. This is that edge we are talking about, right? This particular edge. I hope you can see my cursor. This is that edge we are talking about. And the faces next to it or the face containing the edge. Face containing the edge means there are two faces which contain this edge, right? So this edge, these faces are going to make equal inclination to the horizontal plane. All right. So now let's do this. All right. So let it be like this. So if we look from here, like that, if we look from here, this angle that this face make and this angle, actually it's high. This angle, now I hope you can see, yeah, the angle this side makes versus the angle this side makes is supposed to be equal. Okay, in this particular illustration I believe that it's slightly unequal. So how do we make sure that it is equal? So we must make it equally inclined right from the beginning itself. And how is it made? So it is made in such a way that when we make it, when we draw it in the first place, we let the corner stand like this, like we are, as we are flipping on this side, we make sure that it is a corner on the right handmost part. In the previous example, as it is supposed to be the edge, we are making the edge on the right handmost part. So this is a corner, so we put the corner on the right handmost part. All right, I believe that someone has not muted him or herself. Yeah, I think it's Sinan. All right, so we are making sure that these two lines are making an equal angle to the vertical line already. All right. So as these faces are supposed to be making the same equal angle, we make sure that these two angles, suppose there is another line here, so you are making sure you are aligning it in such a way that these two angles are the same. Okay. Luckily for you, as this is a hexagon, the property is such that when you make this face, when you are making these lines parallel to the VP or parallel to the XY line, so these two lines are going to make the equal angle where whenever they are touching a line. Okay, whenever they are touching a face, which would be the horizontal plane. So we orient our hexagon in this direction with the corner D on the right handmost side. It is going to act as an anchorage. It's going to act as an anchor, as it is the corner which touches the horizontal plane, and as it is the start of the line or the edge where it is going to sleep. So we are forming our hexagon and our front view like this. So now the front view is fixed and we let it sleep. We entirely rotate it, making OD sleep on XY line, and then we get the with this thing. This whole thing is rotated and let it sleep like this, and then from then we are getting the points to get this true front true top view. All right, so what conditions do we get? So the axis is still parallel to the vertical plane, and OD, as it is the one resting on the horizontal plane, OD retains its true dimension. The rest of it are now distorted because of its orientation, because of its um, inclination. All right. Any question? If no, then I will go on. And this is a cylinder, so I want ponder much on it. A cylinder of base diameter and axis has a generator in the VP and inclined at 45 degree to the horizontal plane. Draw its projections. All right, so it is like this. So we have one edges. So generator would be this edge touching the vertical plane, and then it is inclined at 45 degree to the horizontal plane. So it is now inclined, and now instead of a circle, we get instead of a circular prism, or let's say or a cylinder, we get some kind of an oval shaped pyramid, or the cylinder in a distorted way. More or less the same as the ones that we had done. It's just that as it's a circle, we are anointing certain lines or generators
Sir,
like that.
uh, can I please interrupt, sir?
Yes, yes, yes.
Sir, I need to pick up my sister from school, so can we please have lunch break at 1:30?
Yeah, yeah. We will have. Actually, we only have one more topic to go. This thing.
Okay, sir.
Yeah, axis inclined to VP and parallel to HP. But I believe I will have to stretch this after lunch break, because that will be another whole topic. And after that, I will be. Hopefully, I will be able to go on with planes, which are at an inclination to both the horizontal and vertical planes. And after that, we will not move on to projections of geometries. Uh, but we will next week we will move on to isometric projections, isometric views, and then we will finish graphics. And then whatever time that we have left, I believe, which is very less now, by then it will be dedicated for BCM. All right. Now let me explain. Yeah, one more of this. Draw projections of a cube of edge resting on one of its corners in the horizontal plane. Yes. Have I skipped much? Let me just check it once. Yeah, no. Now we have certain conditions like this. A pentagonal pyramid of base side 30 and axis has an edge of base parallel to HP. Its axis is parallel to VP and inclined at 45 degree to HP. Draw its projections when the apex lies in the HP. Apex means the tip that I was talking about. So here we are having a conditions wherein we have an edge of the base parallel to HP. Edge of the base of a pentagonal pyramid is parallel to HP, meaning that it's not talking that it's the entire base. It is saying that one edge of the base is parallel to the HP, and the axis is parallel to VP and inclined at 45 degree to HP. VP is still inclined. So more or less we are going to have a similar situation, but then it is saying that the apex is in the HP, so the tip is in the HP. So we are going to have something like this. So we are first going to, for this particular assumption, we are going to have a base parallel to the HP. So and as such, in our first iteration, when the whole thing is perpendicular to the HP, we are still going to have one side, one edge of the base perpendicular to the VP in such a way that it is parallel to the HP. Okay, when a line is perpendicular to VP, it is parallel to HP. When a line is perpendicular to HP, it is parallel to VP. That is always the condition. So we are making one edge parallel to the perpendicular to the VP to make sure that it is parallel to the HP. All right, and then we get our front view. Now the condition is such that the tip or the apex is touching the horizontal plane. So now we have to invert it in such a way that we are starting from a certain point over here, and then we draw the whole thing wherein the axis is at 45 degree to the horizontal plane. So it is like this. All right. Now we have draw a projections of a cube of h 45 mm. Cube would means a square pyramid of side 45 mm and axis 45 mm. So that is why you need to know many things like a square pyramid can be a cube and a cuboid, but a cube is a square pyramid, and a cuboid can be a cuboid is also a square pyramid. But when we talk about a cube, then the axis is always the same as the side, okay, as the edge, resting on one of its corners in the HP. So how many corners do we have? 1, 2, 3, 4, 5, 6, 7, 8. Right? We have 8 corners, and we have one of the corners resting in the HP with a solid diagonal vertical. So we have a diagonal vertical. Okay, solid diagonal would mean if this is the solid, so the diagonal would be this point touching this point. Okay, solid diagonal. This point touching this point. All right, with a solid diagonal vertical. So first, as we are talking about as our cube is going to be touching the horizontal plane, instead of a face on the right handmost corner, we are going to have a corner on the right handmost corner. Okay, so if the question says that an edge is touching the horizontal plane, then you must make one of the edges on the right handmost corner with perpendicular to the VP. All right. And when we have a corner resting on the horizontal plane, then we should have one corner on the right handmost part in such a way that we can making this even is always helpful. So 45-degree alignment for cubes. So something like this. And after this, what do we have? When we have this, as the question is telling us, we have a solid diagonal vertical. So in this particular orientation, the solid diagonal is pretty much in a diagonal, or let's say in a slant direction, right? It is inclined. So for this solid diagonal to be vertical, we flip the whole thing and make sure that this line is vertical. And the dimension attained from this front view is the same, and it is applied on this front view as well. And after that, we project down the whole points from this side and the points from this side to show the actual front view, actual top view, sorry. So we must always know the different terminologies that can come up. All right. Here you have a tetrahedron. So as I have mentioned, a tetrahedron is nothing but a triangular pyramid. A tetrahedron of edge 70 mm, and they are all equal. All the edges are all of equal size. Has an edge on the ground, and the faces containing the edge are equally inclined in the HP. Okay, sometimes maybe you have a tetrahedron wherein the axis is slightly higher, wherein you have a smaller base. So preferably it would be called as a square as a triangular prism when you have the whole, when you have the axis taller. And when it is a tetrahedron, we tend to have the sides of equal sizes. Draw its projections when the edge lying. I think Lalompuya, you need to mute yourself for a while. Draw its projections when the edge lying on the ground is perpendicular to the VP. All right. So we have a condition when the edge lying on the ground is perpendicular to the VP. All right. An edge on the ground, the faces containing the edge are equally inclined to the HP. So they are going to be equally inclined when you make this line equal, when you make this angle equal. All right, so when we have an edge, so the question is saying that the edge lying on the ground is perpendicular to the VP. We have an edge lying on the ground. So when we have an edge lying on the ground, that means that we must orient this edge on the right hand side. And the question is even further telling us that it is perpendicular to the VP. So it makes the whole thing even more even more simpler for us over here. All right. So here, so what do? So we get the front view over here. We have of our front view. As we are looking it from here, we are simply seeing a circle, sorry, a triangle over here. And then we rotate that, making sure that BC is here. And when we rotate it, we make sure that the angle made by the line ABC and the line DBC is equal. And after we made that happen, all right, because this is already distorted, as this is already distorted, you have to calculate this yourself. All right, you have to calculate this internal angle that you have formed. All right, the angle that you have formed over here, as well as this over here. Okay, so here, as we do not have a height, the thing is, as we do not have altitude, because as it is a tetrahedron, we said the side is all the same, right? As the side is all the same, how do we construct this? From this particular point, we take a line, and then we simply let it go over here. And from here, making a circle is a lot easier. We take an arc of 70 mm, and we touch it over here, and then that gives us 70 mm. Or you can simply rotate your scale and let it meet where the point 70 mm is, but getting a circle would be eventually a bit more accurate. And then you have that. Okay, and you have that. And after that, after everything is obtained, you rotate it and make sure that this angle is the same, and then eventually you get your final projections of this. All right, so point D is over here, point A is here, B is here, C is here. So now it is accumulating, and in this particular direction, we are seeing it as a square. All right. Okay, I won't ponder much. I believe that we may be a bit tired. It has been how much? 2.5 hours already. So we will come back not before 2 p.m. So yeah, and everyone, please, as per the current trend, I believe that people who attend the morning session not everyone used to attend the afternoon session. And trust me, that is on your loss. Okay, so everyone attend, and your assignment will also be revealed on the second session. So I advise everyone to attend the second session as well. And I will give you a new link. I will give you a new link for this one, for the next one. So I will end this meet. And for that, all right. Attendance taken. I will share a new link. Okay.